everyone. As always, now this is our appointment every Sunday for the English version of the book of Fabio Ciucci. This is episode number 9 of from the series of on the book of Fabio Ciucci. As you all know, this book was written in Italian, and he gave me permission to stream it, and to stream it in English and Italian, of course. I like this book quite a lot. I learned a lot from this book. This book has really good examples of how to program the Amiga. I have to start, as always, thanks to Fabio Ciucci for giving me this opportunity. As always, also on the screen on the top right hand corner, you have all our links. Please follow us on Twitch and YouTube, doing a like if possible, and subscribe to the channels. Follow us on Twitter and Instagram, and join us on Facebook and Discord. Discord, I have to say, it's quite important if you miss the links. The links are all on Discord, and you know, we get to know each other. If you want, you can have a chat and also ask things about the book, or what you have learned, or what you have doubts. This is why Discord is basically, so that people can communicate with us without having issues, because I know some people do not like Facebook, so we created Discord so that they can talk to us on Discord. The links, as I said, are always top right hand corner. My aim is to share what I've learned, or what I'm learning in programming the Amiga. We arrived in example number 3 of the book. We read the whole chapter. Remember, there are 2 books. This one, which is the okay, we did all this, and we finished the last let's say theory, and now we are doing the exercise. These are all, those in green are exercises, okay? So it's just a reminder, we have done these exercises till the next one is 3C3, okay? So we are here, but remember that each exercise has got also exercises for you to do, which I did, and I will show them to you. So there is more than that, and I will show you what I mean. So if we go on the Amiga, and we are in 3C3, okay, we are here, but look how many examples we need to go through today, okay? So there are all these examples to go through, and some of them are demo-like examples, so you should like them, or like what you see. I mean, the Amiga was famous for its graphics, let's say nice graphics that it used to show or do in the old days, which I still like, and I hope you guys are nostalgic like me of the Amiga. It's a machine that I like. I like the Commodore 64. Actually, I like all the Commodore machines. Coming from me, yeah. My friends call me Commodore junkie or Commodore freak. But yeah, it's but the most 2 machines that I like are the Commodore 64, which I do code for the Commodore 64. I did start remembering things, but the Amiga, I'm finding it more harder. Anyway, so let's start with showing you, okay, example 3C3. It's hello. It's the first copper bar of the Amiga that we are able to produce. I'm going to explain the code, okay, for those that saw a copper bar and what it does. I'm going to explain it. It also moves, okay, so if I press the right mouse button, it moves down. So and it does a check to see if it hits the bottom, etc. We are going to examine the code and go through it bit by bit. As I said, there are lots of examples that I need to go through. So today, bear with me. I'll try not to take a break so that I finish all of them. Yesterday, I managed to finish in 2 hours 15 minutes. So today, I hope to be able to finish all the exercises in roughly in the same time. Okay, so here is the code that the book, the example that we just show uses. Now, this part is the common part, okay? We have already explained it many times. We open a library, we store the copper, we disable multitasking, and then we jump into our routine, okay? Then we close, okay? We wait for the mouse button to be clicked. If it doesn't get clicked, then we close, okay? So these are standard routines. We have explained these several times now, so no need to go into them. Okay, so before I show you this part, I'm going to show you how the copper list is, okay? So this is the copper list that he is using to form that bar, okay, that red bar. And all it is a wait instruction and changing the color. Okay, another wait instruction, the next line. So here we have 7, 9. Remember, this is the Y and this is the X. Okay, I hope you can see my mouse, the mouse pointer clearly. And then this is, we are putting 3 in, which is red. Remember, red, green, blue, into 180, which is color index 0. And then we change the Y position, we go to 7A and increase the color, the red color. So each raster is having a different color. Okay, but always in terms of red. So you can see it from 3, it increases to 6, 9, C, F, and then he decreases it to, again, from F to C, 9, etc., etc. And then remember, this is how to tell this is the end of the copper list. Okay, so guys, please follow. If you cannot follow it on the book, follow it on the live share. Okay, so that is our copper list, and we have this name barra. Okay, we have barra 1, 2, 3, 4, 5, 6, 7. Anyway, and we are changing, okay, the value here to make it move down. So if we make this 80, sorry, if we make this 7A, this becomes 7B, this becomes 7C, and it continues like that. And we do that by adding a 1. Simple. Okay, so here we're adding a 1 to move the copper bar 1 down. Okay, here we check if we have reached the bottom. So FA, if we have reached the bottom, then we do not move the copper bar anymore. Okay, that is all that is doing for this example. Okay, nothing, you know, you think there's lots of complexity about it, but nothing. The instruction add, we are so for those that know 6502, the 68000 has got lots of instructions similar to the 6502. Okay, you can understand, compare, forget the I, which means immediate, but CMP is compare. A double D is add with carry. What we know with carry is add. Okay, so they are quite similar. Branch on equal, you know this. So even if you haven't followed from the beginning the instructions, they are quite similar. So you should be able to grab, understand it and grab it more quickly than if somebody's come from the Z80, um, background. Not that I have anything against the Z80. It's just that so you should be able to see also my comments, although it will not show them properly, I think. Anyway, it can be disturbing, and I need to figure out how to switch it off. Anyway, so that is all that we are doing. We are just moving the code. We are just adding one to where the Y register for weight is for the copper. Now, first exercise, okay, modifica 1, okay, is to put a remark next to these first 5 adds and leave the rest. So we're going to go to the example. I'm going to remove this for now. Okay, we're going to go to the example, the next example, the next exercise. So read, and we were doing 3C3, right? So then we need to do 3C3 underscore 1. Assemble and run. And look what's going to happen. Wow. It's like an opening. You've seen this happening several times in demos in the Amiga, like something opens and then a scroll text comes in. So this is the beginning of that. You have seen it many times, and it shows that he is a demo coder, and thanks to him that he's showing us all these nice. You will see the more I go through the book, you will see that we will start seeing effects, and this is why I like the book. I'm learning what I used to do in demo coding. This is what the book teaches, So it's a quite an interesting. I don't want to say that it teaches you to do 100% coding, far from it, but it does help in it does help you towards that route. Let's say that. That's all it did. So it went and I can show you the code. So if I show you the code, okay, you will see that it's the same example, but look, the code is with remarks. Okay, so here remarked, commented the first 5, and we get that effect. Nothing changed in the code, so it should be quite easy, okay, to understand if you're following the code. So obviously we're going to do 3-2 and 3-2. Okay, I'm going to show it to you. It does the following. There you go. It zooms out, so it makes the copper bar bigger. It's not anymore on a diet, it got fatter. Okay, so I'm going to show you how he did this, and it's the same code, but he's changing numbers. Okay, so it's quite how to say, it's quite an interesting way of how he did it. So, and this is what he did. So instead of adding one each, he started 1, 2, 3, 4, 5. So each position got incremented with this value, and it creates that effect. Okay, because remember, we are changing the position. Okay, he called it zoom effect. I'm calling the bar getting fatter. um, uh, the by incrementing these numbers, you will see the bar growing basically. So that is all of what he did. So we have example, as you can see here, I have the comment 3c3. So I need to do 3c3 underscore 3. So it's always the same code, but changing something small. And every time you change something small, you see a nicer effect. And remember, we always started with just a copper bar. And this one, I am not going to continue because it does it very fast. I just pressed it a little bit. What it does, it grows towards the top, okay? And it creates that effect. I'm going to show you what happens because there are no checks, okay? So once it grows, it starts again from the bottom, and you'll see it doesn't maintain the same positions as before because the calculation is done differently. So it doesn't make any more sense. But I'm going to show you what he did. Instead of adding, he did subtraction. That is all. So instead of adding the numbers, he did a subtraction on the numbers. Okay? And that's why you see that effect. We are in lesson 3C4. Not lesson, example 3C4. I'm calling it lesson, but it's example. We are still in chapter 3 as always, but yeah. So for those that do not know, A means assemble, J means execute our code, our assembled code, okay? We are using as in Pro. Why as in Pro? Well, there's a bit of story. The book recommends trashing 1, but, or as in 1. However, this is when the book was written. After that, of course, there were other assemblers that came into the scene. And Asim Pro is a descendant of Asim 1, which is has got some nice features in it, and one of them is the coloring of the code, which makes it easier for you to for you guys to see. I'm using Asim Pro to keep with the book. Okay, in reality, when you're coding nowadays, you'll use something like Visual Code. Okay, and then maybe you assemble it in the Amiga unless you use some extension to edit. So I'm using Asim Pro, and I'm doing things in Asim Pro so that I follow the book, because sometimes the book jumps and shows things of how to use the assembler. So I just want to be precise with the book, because else if I start doing things in in visual code, I will not be following the book, and I might confuse you. So that's mainly why I'm doing that. So we have our usual copper bar, and this time it does more checks. Okay, I'm going to show you what he did. The check is the same that he did in the previous example, but he approached it in a different way. So it's the same code modified to teach you something else. Okay, so I'm giving you a heads up of what you're going to see. So it's always the same routine, and then move copper. Okay, move copper. And what he did, you see, before we had a different addressing mode. We were not using this addressing mode. What he did is, instead of having a label for each, remember we had barra, barra 2, barra 3, barra 4. He didn't do that. He used one addressing mode, okay, used one label of barra, loaded 80 with where barra is, and then he created the offsets. Okay, so here we have transparently, in a way, 8 times 0, which is 0, so you can leave it out. And here we have 8 times 1, which is 8, so we can leave the times 1 out. And then you can see the rest. Why 8? Because the difference between where he wants to change, okay, where he's changing the color, okay, is 8 bytes. Okay, so from here to the next one is 8 bytes. If you count them, okay, that's 2. That's another 2, that makes them 4. Hence we have another 4 here, that's 8. So this position where 7A is 8 offset from the current one. So this is why he adds 8, okay, to the current one. And when we arrive at FC, okay, then we finish. Okay, so he's not doing anything else. He's just using a different addressing mode to show you how it can be done. That is all. We have another example. I don't think I did this because it doesn't need to be done. Where instead of using these, what I was explaining, he used the actual numbers. So 8, 16, remember this is hex, 10 is 16 hex, 18, 20, 28. So it's the same number here, but instead of using an expression, he's using the actual number. So here he's telling you that you can use an expression, and here you don't need to use an expression. You can actually have the actual value. I did not do the exercises for this. Actually, they were not exercises, it's an explanation. But yeah. And we arrived in 3D. Let's see. So we did 3C4, and now we do 3D. We finished all the C's and we're starting the D. Assemble J, and here you've seen this several times in a demo. We have our copper bar going up and down. He also shows more than that. He's also showing, just to make you aware, he's put a copper bar at the top, put a copper bar at the bottom, and he's also showing a screen that is 256 raster lines and not less. He's showing a PAL screen, or a PAL, he's expecting a PAL screen to move the copper bar. So keep that in mind. What does he do here? So we have the normal routine and then our move copper, okay? All he does is we have a flag called Ciucci, okay, which is defined somewhere in the code. Suju is defined here. Okay. We check which direction we are going. Okay. And based on the direction, we either add or subtract. So here we're subtracting, and here when we are, so subtracting is going up. Okay. Going down is adding. Okay. And we set a flag when we finish. Okay. If we hit FC, we change the flag so that now we tell it, okay, we're going to go up. And the same thing happens here. So that is all that is doing, and he's using the same code as before that you saw. So this didn't change and this didn't change. You know this already. He just added this part of checking for the flag. Okay, that is all. No, nothing else. Which the flag is either 0 or 255. Okay, so that's how it works. So here we come to the first example, the first exercise that we need to do. So let me see. 3D1, yes, you can see it in my example there. So nothing really changed. It's just the way, as far as I know, and I'm going to check because this one I forgot. So here, okay, he just added that we wait for frames. Okay, we are just waiting. You see the check. Remember, DFF006 is one of the custom registers for the Amiga that gives us where the raster line is right now, and we're making a check that we have reached. If we have reached 255, if we reach 255, if we haven't reached it, we go back. So we are waiting basically we're waiting one frame. Okay, remember the copper is executed 50 frames a second, the copper list I mean, and if we wait for line to 55, that means once we execute it and we start again from the beginning, looping, that is one frame. And here what he's doing is he's checking that we have reached line 255. Then we do our code, and then he does another check. So this is what changed. Okay, he does another check. Why? I will explain in a minute, but I want to show you something. Okay, notice that this copper bar, okay, moves very smoothly. Okay, doing it 1 frame per second, 50 frames per second, goes very smoothly down. Why he has done 2 checks, and I'm going to explain it to you in a minute, so that Ozzy also finishes brushing his hair. I need to do my setup, so he's doing it at the right time. So we have 2 waits. Okay, one, we wait for line 255, and you see branch or not equal, we go back. And here we have a wait, and look what it says. This is on not equal, and here it says on equal. If we are still on line 255, okay, we go back to aspetta. Why? Because this routine is too short. It will get executed within one raster line. And because it gets executed within one raster line, if we don't do the check, it can be that it can be executed twice on one raster line. Okay, so that's why we are doing that. I'm going to show you what I mean. Okay, so if our raster line, okay, if our raster line is, oh god, anyway, that's our raster line. Right now, sorry, but I didn't have my hand firm to do it. We start from the left side of the screen, okay, and we end at the right side of the screen. Now let's change color. So if we checked if we are on line 255, let's say this is line 255, okay, I'm not able to write straight for some reason. So we are on line 255 and we started executing our routine. Okay, we started executing it here. Our routine is very short, so let's say it finishes somewhere here. Okay, it did. So this one, when we started here, it moved the copper bar, okay, either one down, okay, let's say it moved one down, okay, let's say it moved one down, okay, so our copper bar moved one down and we finished, okay. Because our code is too short and the raster line hasn't finished, when we did the check, okay, we said, have we reached line 255? And we did a check and we said, yeah, it finished, so we can execute our routine. Once we exit from the routine, okay, we are still on line 255. Okay, so the code might get executed again. Okay, for that we do the second check, branch on not branch on equal. So make sure that we do not execute the same routine once we are on the same raster line. That's what he's doing. Okay, it's very important. This is a bug, let's say coding bug, that I fell trap of, okay, in the past. When the routine is too short, you might execute it more than once. Okay, so imagine if you were supposed to be moving the bar 50 frames a second, you start moving the bar, okay, 100 frames a second, because in one frame you're moving it twice, so it becomes 100, okay, not 50 as it should be, 50 FPS. And that is the issue that yes, this is a very common bug in accelerated Amigas, but I had it on the A500. I tell you, when you write some small stupid routine that you wanted to wait for on a, so even the 68,000, okay, A500 will suffer from this, okay, but on faster machines it's even more common. And later on, I think it's the next example, he's going to show us what happens, okay. But for those that are new, it's good that he's explaining it, because you can easily fall trap of this issue. Okay. So this is why we are checking if we are online 255, and then are we still online 255? That's all. Okay, nothing changed in the code. He just added this line. Now, what he's going to tell us, okay, and this is the next example, okay, look, actually I'm already there in the next exercise. He tell us to do a remark and do not check for, we won't check for those lines and see what's going to happen. Now remember, I'm running my WinUAE not using a 68000 processor, but I'm using a 68030. But I'm not like other people. What they do, they make it run as fast as possible. I'm using the timings of them, so it's emulating a 68030 as if it was in a real Amiga, let's say A3000 or A4000. Okay, so I'm not executing my code as fast as one can, but as fast as the 68030 would. Okay, so I'm using the same perfect timing. So you're going to see this happening in the next example, which actually I was there already. And there you go. It's being updated twice. Okay, that's the issue. You also can see that it's a little bit jerky, because of course it's like sometimes it cuts itself in the middle, the copper bar. So yeah, and you can see that it's not so smooth. So yeah, this is the issue, common bug, let's say, that and of course you're seeing it even more on a 68030. And also you can see it moving in like, sometimes it's like move fast and then it stops, and then move fast and it stops. So it's a common bug that somebody might encounter while coding on the Amiga. Okay, we finished 3D, and we should enter 3E. Sorry, we should enter 3D2, I believe. And let's see if I'm right, because so I did 3D2 and I explained it to you what happens, okay, with the frames. And yes, we are entering 3D2. Now, here's a lovely trick, which I wish I knew 30 years ago when I was coding. I used to do it differently. It's still the same, but this trick, I liked it more. I didn't know about this trick, and I'm going to explain it in a minute. Now, what happens, let's say you want to do it 1 frame per second. Sorry, 1 frame. So 50 frames per second, okay? So 1 frame each time, okay? Instead of having a flag, okay? It was much more easier, okay? It is much more easier. So to have, actually, instead of using it the same in 1 frame, let's say we want to do it every 3 cycles, every 3 frames. Let's say we want to move the copper bar every 3 frames, okay? So that is roughly every 17 frames. We need to do it, 50 division by 3, okay? So 50 division by 3 is roughly 16.6 something, so it's 17. Every 17 raster lines, we move the copper bar, okay? No, sorry. We are having 50 frames per second. Every 16th or 17th, every 17th frame, okay, we move the copper bar. That's the right wording. I was confusing you. So if we divide it by 3, as I'm saying here, it will be 17 frames, okay? Because we have 50 division by 3 is 17. If it was NTSC, which is 60 frames per second, we will divide by 3 and we get 20 frames per second, okay? But this is 17 frames per second, and this is the trick that he uses. So the first time, okay, we wait for 255, okay? The second time, we wait for 254, okay? So this is 255 here, and this is 254, okay? We still haven't done our code, we're still waiting. So we did 1 frame, we jumped into the second frame, and we said we wait for line 254. But we also wait for line 253, okay? FD. By waiting 3 times, by waiting 3 frames, okay, we have done what we need. And then we move our copper bar. So it's all he's doing. If you see, this part of the code didn't change, it's still the same. Just we have this check here, okay, for the wait, okay, and that's why it moves more slowly. Did I show you the code? I don't think we did. This is 3C. I don't think I showed you this. We are in 3d2.s, so we need to be 3d2 underscore 1, I believe. Yeah. No. That's a different example. Yesterday I got confused in the same thing. My God, so annoying. Because the Amiga cannot sort directories. Okay. We were doing 3D, 3D2, 3D. Okay, I need to look at the book, else I will not follow. Sorry, guys, but it's for your own good. So this is example 3D2, and we did 3D2, 3D2S. So let's find 3D2S, and that is what I just showed you. Not really. 3D2S. How did I arrive there? I must have jumped something. And yes, I did. You see, I should have not done 3D2S. I should have done 3D underscore 2. 3D underscore 2. Actually, let's do 3D underscore 1. So this one, let's see if I'm right. Is what we were talking about, waiting for this screen. Why we need to check twice, okay? So 3D underscore 1. So 3D underscore 2. And this is doing it 100 100 times per second. So we did those. So what have I missed here? I'm just going to explain it, okay? Just bear with me, and I won't show the examples, unfortunately, at least till I find them. So I was saying, so we are doing this example, okay? That if we wait FF, then FE, then FD, okay, we are skipping 3 frames, okay? And that's basically it. The code remains the same. Do I have no? And then basically we do it every 3 frames. (3D2_1). So we arrived here now, which is this one. I know 3D2_1. Read 3D2_1. Yeah, we arrived here. So what he does here, okay, you see that in the middle it's like a cut. Basically, he is waiting for, instead of the Y, I mean he's waiting on the Y, but also on the X. Okay, so so what happens is that he created an effect, okay, by waiting, okay, at a particular instead of 7, which is hidden, okay, at the beginning of the line, he's waiting in somewhere in the middle of the line, okay. That's why actually he's waiting at position 87, okay. Now he's asking us to change one line, we leave it at 87, the other one we change it to 67, okay. And because of that, he's going to create an effect of zigzag, sort of, and he will create this effect, okay, on the copper list. Okay, so I'm just going to show you that before we jump into 3E. So can you see the effect that he created, okay, here, okay. It's like curtain, okay, folding. So imagine you wait on the screen several times and you create that wavy effect on the copper bar, and it will look like a curtain, let's put it this way, or something, zigzag way, in a zigzag way, and it's quite a nice effect. So that's basically what he expect. So that's basically all that there is to it. The code is always the same, okay, nothing changes. See, he's doing an addition and an addition and the subtraction, okay, and the flag, it's always the same code, nothing changed, okay. And here is, I can explain it here, okay, with the code. We're waiting 3 frames per second also here. You can see, so that is being moved every 3 frames, that copper bar. So we'll wait to 5.5. once we wait for raster line 255, we wait for raster line 254, then we wait for raster line 253, and then we do our move of the copper. Okay. Then we move the mouse. Okay, and then we close the usual way. So nothing changed. Okay, let's do 3E. And now we have the first copper bar cycling. Okay. It's an effect that you've seen many times. Okay, so what is he doing here? It's a very simple routine. Basically, what he's doing, okay, I mean, we are also waiting. We're also updating the screen every 3 frames, okay? Sorry, not every 3 frames. Every 3 frame cycles, okay? So 16 frames per second or 17 frames per second. But what he's doing, okay, is very simple. We're copying what we have in color position number 2 into position number 1. Remember, this is our copy list, and we're copying the color. Okay, we're copying this. Let's do 2. We're copying the color of number 2 into the color of number 1. Okay, so F0 becomes D0. Okay, and we are cycling. Okay, we're cycling it. That is all. So we do it till the bottom, and then we do it again and again and again, and we'll see the color cycling. Okay, cycling effect. That's basically it in terms of this exercise. So that is all. Nothing special. But the next one is quite interesting. Okay, I do like the next one quite a bit. It's quite a neat trick of what he does. As you can see, I did this so many times that I started to know things by heart in a way. Notice the copper bar changes color and cycles through all 4096 colors. It's still our same copper bar, but it goes from green to red to yellow to blue, all the colors of what we have. Actually, it's not doing blue, sorry, and there's a reason why. I will tell you. But yeah, so it's cycling the red and the green, but not the blue. Okay, so all the possible colors with the red and the green. And I like this effect quite a bit. How he's doing it? Simple. Same routine as before, copying, but he's adding 100 to each position. 100 hex, okay? So that's all he's doing. To column 13, okay? At the bottom, he adds 100, but then remember, column 13, color 13 moves 1 up, okay? And the next one that comes in, okay, is also added 100, okay? But then, let's say it's cycled again. So what we have on top comes to the bottom. Then it becomes, if what we had in color 13 was D0, okay, and then we made it 1D0, okay, then it's going to be 2D0 and 3D0 and 4D0 and all that stuff, and so it cycles, okay. So that's how he's doing That's how he's doing all the colors of what I said. It's quite a nice trick, quite a nice effect. But that is all. Okay, and we arrived in 3F. 3F. Now we have 3 copper bars here. You have a copper bar on top of the screen. Okay, you have a copper bar at the bottom which is red, and then we have another one that is moving. What is he showing here? He's showing that we have a screen that is 256 raster lines, so we are using PAL, and he is moving the copper bar in the PAL area of the screen. That's what he is. And what he wants to show us is the command in the copper to make it in the lower part of the screen, so that we have 256 raster lines. Okay, so 3F is always the same exercise. Okay, nothing changes. You see, going up and down. Okay, but in the copper list, he added this line. Okay, this is, we wait till line 255, and then we know, the copper knows this is an impossible X position, so it jumps to the next one, and we know we are in we know we are in the PAL area of the screen. Okay, that is all that he's explaining, nothing else. You will need to include this in your copper list to do the last bottom part of the screen. Okay, so from 3F we do 3G. Here we have our simple line 1 raster line, and we are changing the X value of it. It has 2 colors, this raster line, white and red, and we are changing the position of the X value so that we see it moving up and down. You've seen this a lot on the demos related with music. Okay, so it's not something out of this world what he's showing. You've seen it, but it's done using, we are always in the same Y position, but we're changing the X. Okay, how he does it? Very easy in a way for those that can understand the code. He has, so he knows that there are 85 positions on the X axis that we can move our bar, which we can change the color. And what he's doing is, he is, every time he moves the X value, he's also adding 1 to a flag. Okay, so that he knows where he is in the X value of on the screen. Okay, so he has a flag called Destra flag. Okay, and he knows that if he reaches position 85, he needs to change back and starts doing a subtraction instead of an addition. Here he's adding to the X, and here he's subtracting to the S. So moving to the right, moving to the left. Okay, or changing the color white. Okay, where it stops from white to red, doing at the position. So remember, the X position has to always be an even number. So 7, 9, 11, 13, and continues like that. And he is changing that. Where is the copper list? There you go. He's changing the position here. So that 31, okay, becomes 33, 35, 37, 39, 40, and it continues like that. I set them in decimal, but you got the point. It happens in hex. Okay, so all he's doing is changing that value. Of course, because he cannot read it back, he had to create a flag that tells him how many times he has moved the how many times it has happened. So when it happens 85, he knows he has to change. That's all. It's nothing in this code that is not clear, I believe. Here is doing a test. Did we move 85 times? If not, we go and do to move to the right. Okay, we add 2 to the copper and we add 1 to our flag and return. Okay, that is all. Return to the subroutine that called it and continue executing the code. So not really anything out of this world. That's all that code does. Okay, we arrived at 3G. Or we did 3G. Yeah, we did 3G1. We arrived at 3G underscore 1, sorry. Now, although you're seeing the same thing, he wants to tell us something. Start from here. I was here. I explained the issue of the flag, how the flag works, and what is our maximum value, which is E1 going to the right. Okay, so that's why how he counts to 85. Then he explains that if you put an even number, okay, instead of an odd number to the copper, it freezes. Okay, now if it freezes, you reset, it's fine. He says you can use this trick to if somebody copies your disks, let's say, okay, he says you can use this trick to, if you detect that he did this, to basically freeze his Amiga. You do not get a guru when you do this trick. Okay, no way the Amiga will display a guru. Okay, it's frozen. The disk drive stops clicking and it freezes completely. So you need to be careful in when you are, let's say, coding the copper, not to make this mistake of putting an even number instead of an odd number. It doesn't like it. So instead of having let's get the book. So what he's doing here is the same routine as before when we had one line, okay, but instead we have 16 of them, okay, 16 raster lines, and he created this routine to replicate, to move the white, let's say, per raster line via this routine. That's all he's doing. Nothing changed in terms of so imagine instead of having one line, we're having 16, one next to the other. Okay, and so he is changing the X value when the color changes of all 16 of them in one go. Okay, and then do it again for all 16 and do it again and do it again. So it's the same routine, having a flag. You see he's checking for 85 positions and then doing the addition and subtraction. You see you have a subtraction here and an addition here. Okay, so the same routine, but he's doing a loop to do the addition and the subtraction. Okay, and then of course he sets his flag, we add 1, so this part was coming to the previous routine while he added this loop. Sorry, he added this part of the loop. Okay, that's all what it is, like building blocks, no, one on top of the other. That's how he managed to get 16 in the X position moving. That is all. It's you know, you've seen this many times in demos and in things that the Amiga have or had. So our Amiga still going, and as you see, we came to an end of our let's say exercises of chapter 3. Next week we will do chapter 4. We'll start chapter, which is screens. Have a good week. See you and bye.